Hello everyone, welcome back to my channel. What's on the agenda today? Today we're taking a look at the Claude Code CLI and testing it together with our MCP Server V.I.N.C.E.N.T and the bagueDEV community launcher. But we're not testing Claude Code with an Anthropic subscription. No, we're testing it with a local LLM running on our budget setup. One of our goals is to clear up a myth, the claim that it supposedly makes no difference whether you use the Claude Code CLI with a subscription or with a local LLM. Right now, we're seeing lots of videos claiming $0 token costs, Claude Code with a local LLM, but in the end, it turns out that either the performance isn't real or there's secretly a subscription involved somewhere. And today, we're continuing our Gemma-4 test. Specifically, we're taking a look at the Gemma-4 at 26B for B.I.T. Quadtat Q4_KXL.GGUF running on the 8GB Vega 56. We're interested in several things. Do we run into context issues? What about speed? And how does the model behave in terms of agentic capabilities? But most importantly, does our custom-built MCP server actually work smoothly with Claude Code? And does our launcher pass the model to Claude locally in a stable and reliable way? At the end, we'll also take a look at the statistics Claude provides, meaning token usage and cost according to the usage display of the Claude CLI. Okay, we can see that the test has already started. The MCP server has been initialized inside Claude Code, and we've written and sent a prompt. In this test, the model is supposed to generate a game. The instructions for that are prepared in an agents.md file. The game is meant to be programmed in 5 phases, and as you can see, we've already begun. Before we dive deeper into the test, let's take a quick look at the 5 phases our game will go through. Phase 1, player and shooting. This is where the foundation is built. The player can move, shoot, and we establish the core mechanics everything else will rely on. Phase 2, enemy formation. Enemies fly in, lock into formation, and set the stage. This is the moment where the game starts to feel alive. Phase 3, enemy attacks and player lives. Now things get dangerous. Enemies begin attacking, projectiles enter the scene, and the player gets a live system. Phase 4, waves and progression. The game gains structure and long-term motivation. Waves, increasing difficulty, progression, all the elements that make an arcade game engaging. Phase 5, polish and boss mechanics. Finally, we add the finishing touches, effects, atmosphere, and a boss as the highlight. This gives the game its final arcade feel. As always on this channel, we try to blend technology with a bit of music, and you can already hear the fitting track playing in the background. This test took an extremely long time, so I've shortened it as much as possible and sped up the footage for you. In total, the session ran for about 8 hours. And yes, quite a few things went wrong along the way. You'll see all of that in this video as well. And here we can see it. All directories and files have been created. Now the model is verifying everything, starting the Python server and serving the balgaga.html file over HTTP. And indeed, after about 27 minutes, we get the message that Phase 1 has been completed, along with the question of whether we want to begin Phase 2. Right now, the model is summarizing Phase 1 again, and as mentioned, the whole process took around 27 minutes. You'll find more information about the hardware, backend, and token speed in the description as always. But here's the quick version. We're running llama.cpp over Vulkan on Ubuntu 22.05 LTS. Phase 2 has now begun. The machine is heating up, the GPU is running at full throttle, and you can see all the details on the right side of the screen. And don't forget, with this hot weather, make sure you stay hydrated. I'll leave you alone with the music for a moment. And now we're seeing it for the first time, the model starts to stutter. 3 write attempts have already failed, but it keeps going and continues trying to complete phase 2. This phase is already taking longer than phase 1. We're at around 40 minutes and over 13,000 tokens consumed. Will the model finish the phase? Stay tuned, things are getting interesting. Phase 2 was successfully completed after 1 hour and 15 minutes. We'll take a quick look at the summary and then move straight into phase 3. By the way, I haven't even tested whether phase 1 and phase 2 actually work. We're saving that for later. In total, we're now at almost 2 hours of runtime. And as I mentioned at the beginning, this is a long and exhausting test. After roughly 2 hours, I decided to abort phase 3. Nothing was happening anymore, the server was still running, everything looked fine, but something clearly wasn't right. So I shut down Claude Code and the server and started a fresh session. This time, I simply told the model, find the problem and fix it. I'm hoping it understands that and actually finishes the project. At this point, the test has reached 4 hours total and it's getting really warm, both inside and outside. I had to abort this attempt as well. I noticed that the model suddenly started reading data that had nothing to do with the project. It was pulling information from the bagueDEV community launcher. Because of that, we lost around 30 minutes. I think the prompt was simply too vague. On top of that, the V.I.N.C.E.N.T MCP server has a few safety policies in place. Maybe those caused the issue. So we're starting a new attempt now and adjusting the prompt accordingly. Slowly, I'm starting to wonder whether this still makes sense, or whether we should just stop here. But the curiosity is simply too strong. Still, it's impressive what's possible on a Vega 56 with only 8 GB of VRAM. And credit goes to the quantization methods that make it possible to run a Gemma-4 at 26B A4B model in the first place. And yes, I knew from the start this wasn't going to be fast. What I'm really interested in is this. How does our MCP server behave with Claude? How well does our launcher work together with Claude? And does the 26B model actually do what it's supposed to do? 25 minutes and 9,000 tokens later, we're seeing one of the model's strengths. It summarizes its plan in detail and clearly explains how it wants to fix the problem. Everything is nicely structured, and it even asks us whether we want to continue. The best part, it wants to complete Phase 3 and Phase 4 in one go. Sounds good to me. And to jump back to the beginning for a moment, download Claude CLI and use Claude for free? Yes, that's partially true. But in this case, without our V.I.N.C.E.N.T MCP server, none of this would have been possible. Even if you use a local LLM with Claude Code, it won't get you anywhere if it doesn't use Claude skills or Anthropic tools. Back to the test, we have confirmed that the model should continue, and we can also see that it has already started. As always, we record on the same machine, so I stop the recording every few minutes. In the end, I had 35 recordings. Luckily, I didn't have to sort them manually. But we didn't shy away from the effort because the context keeps getting larger. In the background, you can see we are currently at roughly 5.4 tokens per second, and the prompt processing speed has now dropped to 29 tokens per second. For comparison, at the beginning, our best value was 7.2 tokens per second for generation and 68 tokens per second for prompt processing speed. The strong HBM memory with its high bandwidth still brings a lot here. We've just crossed the 10,000 token mark in about 33 minutes. Right now, we're seeing a small writing error. I'm hoping it still pushes through. At this point, we've been testing for so long that we really want to see the end. Will we get a working game? Does the context even hold up? We started with 131,072 tokens, with a maximum of 8,192 tokens per response. Or will the Vega 56 buckle under thermal limits? What is V.I.N.C.E.N.T doing? How reliable are the tool calls when the context gets huge and the steps get complex? And what limitations does Claude actually run into? All of these are questions we hope to answer by the end. If I counted correctly, the test has now been running for 6 hours. As mentioned, I paused the recording multiple times, which is why you'll see bigger jumps in the video, but I assure you, the test ran continuously the entire time. Now we're seeing several red messages and even an error editing file. At this point, 1 hour and 23 minutes have passed, and the context has grown to 24,400 tokens. The message claims that Gemma-4 is not available, but the timer keeps running, and when I check the terminal, the server is still active. Even the bagueDEV chat UI, which monitors the power usage, shows full load. So what should we do? Wait or abort? All right, I'm going to take a look at the project myself and try to start the game. Let's see what happens. As I said, I haven't tried starting the game yet. I'm just as curious as you are. What's waiting for us? And look at that. The game actually starts. Score and lives counters are there, shooting works, hits register, and the controls feel good. The bricks disappear, and points are counted. But it's still buggy, or rather, some features are missing. For example, nothing happens when you defeat all enemies. And the physics behave more like a loop. The bricks should move slightly downward after each step. Still, the foundation is there. Yes, it's playable. Most likely, the parts that should happen in Phase 3 and Phase 4 are simply missing. We'll find out. We're not giving up now, we're pushing through and hoping everything goes smoothly. At the end, we'll also take a look at the usage inside Claude Code and other statistics, and of course, we hope the game will be fully playable in the end. Wow, first of all, the Vega 56 is handling 2 hours and 15 minutes of compute load incredibly well. And second, our context has grown to 37,000 tokens. It really looks like we're getting close to the end. Right now, in the thinking process, we can see the model finishing the last file. Temperatures look good, and VRAM usage is sitting at around 7.5 gigabytes. I'm genuinely curious whether we're about to get a success message or if we'll run into another API interruption. Just as a reminder, we're running Claude Code completely locally, without any internet connection, and with our own tools. Up to this point, I have to say, great job and very stable. A simple setup: llama.cpp, V.I.N.C.E.N.T, MCP, and Claude Code CLI. We've already tested the Gemma-4, 4B, and 12B models. Feel free to check those out as well. In those tests, we used the native llama.cpp UI, including MCP. Let's take another look at it. One quick note up front. When we say Gemma-4 is the fastest, we actually mean the Gemma-4 4B model, not Gemma-4 as a whole. Saying the 4B model makes it much clearer since Gemma-4 also includes the 12B and 26B versions. So, here we've tested all three Google models and you can really feel the differences. Of course, the 4B model is the fastest, but the 12B model, which we just tested, is definitely not slow and has its own strengths. For example, I couldn't finish a project with the 12B model because the interpretation wasn't quite right. The 26B model, on the other hand, cleaned everything up, got it running, and even added extra features. Sure, it took a while, but it worked. So here's a workflow that might be a great fit for an 8 GB setup. Planning with the 4B model, fast, responsive, great for structure. Building the core with the 12B model, stronger reasoning, more reliable implementation. Final polish with the 26B model, deep understanding, better corrections, more features. We did it, as you can see right here. The LLM has posted its final summary listing everything it accomplished and reporting crunched for 2H36 mint. It also tells us that the game is ready to play and even provides helpful instructions on how to start it. And that's exactly what we're going to try now. Before that, let's quickly go through the timeline again and take a look at everything we've done so far. In the meantime, I already started the server, but noticed that I had to change the server port because it was already in use. Quick fix, and the game launches. The game is running, and now we can see that enemies are actually shooting back. We also notice a new counter, which is probably meant for the levels. Shooting and steering work well, and the physics feel slightly different compared to the earlier version. Dying works correctly and is counted properly. We even get a game over screen with press space to restart. But just like in the first test, no new levels are being generated, and some bricks mysteriously disappear without being hit, so yes, there are still bugs. Still, the game is playable, and we definitely have a solid foundation here. With some fine-tuning, this could be polished into something much better. But we're not doing that today. 8 hours is already quite a long session. We'll take a look at the summary now and then briefly check the Claude Code usage statistics. Honestly, this was my first full session with the Claude Code CLI, and it performed really well. I've tested several CLIs before, and I often ran into issues, hard limits, or features that simply didn't work for no apparent reason. But let's make one thing absolutely clear. There is no real Claude Code without an Anthropic subscription. That's the only way to get the full power. Yes, you can recreate some skills, tools, and plugins yourself, but it's not like many videos claim. Claude CLI plus a local LLM is not the same as Claude with Opus. So, here's the usage tab. We're looking at a total estimated cost of $1.86. Of course, only a rough estimate since this is an unknown model. We've got 47,900 input tokens, 32,500 output tokens, and 1.6 million cache read tokens. In the stats section, we also see a total of 671,200 tokens spread across 15 sessions. There are a few more statistics available, but to be honest, I haven't fully figured out how to interpret all of them yet. I'll need to take a closer look to understand what each one actually means. So, that was our test for today, and what a test it was. To sum it up, yes, it works. Claude Code CLI with a local LLM, our V.I.N.C.E.N.T MCP server, and the bagueDEV community launcher, all running on a budget Vega 56 with just 8 GB of VRAM. 8 hours of testing, a few interruptions and setbacks, but in the end, we had a playable foundation. And to me, that shows something important. Even with older, inexpensive hardware and a clever setup, you can achieve surprising results if you bring time and patience. And above all, today we clearly saw that there is a big difference between using Claude Code with an Anthropic subscription and using it with a local LLM. The myth of $0 cost and full power should be a bit more grounded now. Without our own MCP server and without the right tools, nothing would have worked here. And even with them, it's still a compromise, not a replacement for real Claude power with a subscription. I hope you enjoyed this test as much as I did, even though it got pretty tough and lengthy at times. Thanks for sticking with me all the way through. If you liked the video, feel free to leave a like, and if you haven't subscribed yet, now's the perfect time so you don't miss any of the upcoming tests and benchmarks. Until next time, take care.